Alright, so in this video we want to actually practice drawing the graphs, and there are kind of 6 main steps, although we can summarize them in 4, which you can see in the bottom right corner. So I would recommend maybe jotting those 4, the summary version down, jotting that down so you can use it as a reference as we're going through these. But here are the things we have to do. When we have rational functions, and this is not going to make a whole lot of sense till you actually see an example in another page, but we'll start out by factoring anything that can be factored. Okay, then we need to find intercepts that will give us points on the graph that we can do. Okay, then we need to find those asymptotes that we just talked about, the vertical and the horizontal asymptotes. And then once we have that, we're going to have a pretty good picture. Anything that's missing in the picture we can fill in using a table of values. So there's just 2 things I want to mention. First of all, vertical asymptotes occur when the denominator equals 0. So I want to show you 2 examples here because there's a distinction to make between what's called a vertical asymptote and then another case where you would get a hole in the middle of your graph. So here are my 2 examples. Let's suppose I have 4 over x minus 3 times x plus 4. That's my first example. And then I have 4x minus 3 over x minus 3 times x plus 4. So obviously you can see they're very similar examples right here. This first one right here, I'm going to say has 2 vertical asymptotes because vertical asymptotes occur when the denominator equals 0. So what is it that's going to make the denominator equal 0? Well, x equals 3 would make that one 0, and x equals negative 4 would make this one 0. So those right there would represent 2 vertical asymptotes. VA is just an abbreviation for vertical asymptote. Okay, part B, or equation B right here, only has 1 vertical asymptote, and that's at negative 4. That's a vertical asymptote. In that case, what is x equals 3? Because obviously x equals 3 would make this one 0, so it must do something. And this tells you right here, when you have the same thing on the top and the bottom that can cancel, we just canceled those x minus 3's, that doesn't produce a vertical asymptote, that produces a hole in the graph. So what it would literally look like is you'd have a graph, and then right at x equals 3, there'd just be a hole right there, and then the graph would continue on after that. So we'll see what that looks like when we actually graph. And then the horizontal asymptotes, there are 3 special cases. I'm going to show you an example of each one of those cases. And right now I'm going to show you, numbers don't matter, but I'm calling this one case 1. Okay, so case 1 is when the degree in the denominator is larger than the degree of the numerator. So here's what I mean by that. This is x squared. This is x to the first. The largest power in the denominator is bigger than the power of the numerator. In this case, the horizontal asymptote is always going to be y equals 0, and I'll tell you why. Remember that we said in the previous video, horizontal asymptotes occur as x goes out to infinity. So even though you can't do this, let's pretend that we were plugging in infinity for x right here. So we're going to plug in infinity there, and at the bottom we're going to have infinity squared plus 6 infinity plus 8. I know this looks kind of weird because you can't really plug infinity in like you can plug in a number, but let's just kind of go with it for now. Okay, on the top right here, the thing that's going to really dominate is the 2 infinity. Infinity is so much bigger than negative 4 that the negative 4 doesn't even really matter. Once you get out to infinity, infinity takes over. On the bottom, 8 doesn't matter compared to infinity, and if you compare infinity squared with 6 infinity, infinity squared is way bigger than just regular infinity. So this becomes like negative 2 infinity over infinity squared. We'll pretend that were negative 2x over x squared. You could cancel these x's right here, and you'd be left with negative 2 over x, where we're choosing to call x infinity right here. So what does that equal? Well, any number over infinity gets really, really close to 0. We saw that in the last video. We were doing 1 over x, and we kept making this number bigger and bigger and bigger, and y ended up approaching 0. So that's why in a case 1 example, when the denominator is bigger, our asymptote, our horizontal asymptote, will always be equal to 0. So we will record that as part of our steps. We're just going to step through this. So let's just note that right now. Horizontal asymptote, y equals 0. And then we'll continue from there. All right, so first step right here in our summary versions, we want to factor. So the top has a common factor of negative 2. If we divide this by negative 2, we get x. We divide that by negative 2, we get plus 2. The bottom, we can factor by saying what multiplies to 8 and adds to 6, and that would be x plus 4 and x plus 2. So we're done with step 1. Step 1 was to factor. Step 2, find the intercepts, the x and the y-intercepts. So let's do that right now. So x-intercepts and y-intercepts. And actually I really should have these reversed. Let's switch these. Let's find the asymptotes first. And I don't mean to confuse you with that, but it's easier to find the asymptotes first, and we'll see why. So we've already found this asymptote y equals 0, so I'm just going to plot the line right there. So we have y equals 0 as our horizontal asymptote. The vertical asymptotes, where will those occur? So the vertical asymptotes, remember that we said before, the vertical asymptotes occur when the denominator equals 0, and there's two places that happens. It happens here. If x equals -4, that would be 0, and it happens here if x equals -2, that would be 0. But I'm going to claim, or I'm not going to claim, I'm going to show you that the only one of these is actually a vertical asymptote is this one. And I want you to think about y based on what we said on the prior page. Y is only -4 in asymptote, and yet 2 is not, or -2 is not. And the reason is because you can cancel these out right here. So if you were to cancel those, you'd have -2 over x plus 4. Now it's only x equals -4. That would create a problem in the denominator. What you do have at -2 is you have a hole in the graph. Okay, how do we find where that hole is going to occur? Plug in -2 right here. So if you plug in -2, you have -2 over -2 plus 4 is +2, and that equals -1. So we're going to have a hole at the point -2, -1. So that's going to be right here. There's literally just a hole in the middle of the graph. And the asymptote is going to be at -4. So I'm going to draw this purple line. That's our vertical asymptote. Okay, now here's the thing. Here's the rest of this graph. Now we can move to the x and y intercepts. And notice we have one asymptote. We have one vertical asymptote. That means our graph is going to have two regions. There's going to be a region over here to the left, and we're going to have something over here on the right. If we had 8 vertical asymptotes, we would have 9 regions. If we had 99 vertical asymptotes, we'd have 100 regions, and so on. So let's find the intercepts. So we took care of asymptotes and holes. I know we're going out of order there. Let's find the intercepts now. So the x-intercepts occur when y equals 0. If you take this function up here that we factored, ask yourself when, in this scenario, when would y equal 0? And the answer is the only time it could equal 0 is if the top equals 0. And the top would equal 0 at -2. You can't make y 0 down here because you'd be making the denominator 0, and that doesn't work. Well, we can't use that because x equals -2. We already plotted that, and we saw that that's a hole. So this doesn't actually have any x-intercepts. It's never going to touch the x-axis because at -2, which is the only thing that makes y equal to 0, at -2 we don't have an intercept. We have a hole right there. Okay, the y-intercept occurs when x equals 0. So now let's take that same equation that we had to start with. I'm using this equation up here, by the way. And I'm going to plug in 0 for x. So 0 plus 2, 0 plus 4, 0 plus 2. The top becomes -2 times 2 is -4. The bottom becomes 4 times 2 is 8. So -1/2, that's the y value, at an x value of 0. So 0, -1/2, that's going to put us about right there. And that is our intercept right there. Okay, now, so we took care of the factors, we took care of the intercepts. The last thing we do is draw the graph by making a table of values. So let's do that. And really, to get a good graph, in general, we just need 2 points in each region. 2 points to the right, 2 points to the left. Notice that we already have 2 points on the right, so we can just connect these. If I connect the dots, now one thing that might immediately occur to you, hey, I thought that was an asymptote. Why are we allowed to cross it? And the answer is you can cross the asymptote in the middle of this graph. So we're pretty close to the vertical asymptote right now. It's okay to cross right there. It's not okay to cross as you get way out here to infinity. So what's going to happen is this is going to come up like this, and it will start to skim that asymptote right there. And same thing, this is going to come up there. So we weren't sure if it's going to go down here or up here. It has to go up here because that's the only way for us to connect those 2 points we had. So that's the right region of the graph. Let's get the left region. In order to do that, we need, this asymptote here is -4, so we need 2 values to the left of -4. Let's use -5 and -6, and we're going to plug them into this right here. So if we plug in -5 right there, we'd have -2 times -5 is 10, -4 is 6, and the bottom would be -5 squared is 25. 25 plus that 8 is 33, and 33 minus 6 times -5 is -30, so 33 minus 30 is 3. So that gives us the point 2. So negative 5 comma 2 is on the graph right here. We just need one more point because right now we're not sure, is that going to go up here or down here? So we need another point, and the other point will tell us which way it's going to go. So let's take, we said negative 6 would be our other point, so we'll plug in negative 6 right here. Negative 2 times negative 6 is 12 minus 4 would be 8. If you plug in negative 6 at the bottom, negative 6 squared, 36 plus the 8 is 44. And then plug in negative 6 there would be negative 36. 44 minus 36 is 8, so 8 over 8 is 1. Negative 6, 1. Now we know that when we connect them, it has to go up right here, and it has to go down right there. So that's what our graph looks like, the graph of this function right here. And that, like we said, is a case 1. It has a horizontal asymptote of y equals 0, and the function is going to look like what you see right there. Yeah, actually, you know what? I just noticed something here, and this is, should have noticed this earlier. I believe we plugged in, sorry, way back here, and I'm sorry to confuse you with this. That was the right point, but negative 2, negative 1, for some reason I put a point at negative 2, positive 1. So that hole should be actually right here, and this is our other point, so our graph should be going down this way. So I apologize for that confusion right there. Let me erase this right here. So everything was right there, except for some reason I put the point at negative 1. So that is the only thing that we need to fix there, but otherwise this graph is the correct graph.